This is a lesson on 1.4, analyzing graphs, analyzing functions, and we choose the categories we want. I have chosen domain, range, symmetry, zeros, relative maximums and minimums, and where the function is increasing, decreasing, and constant. So, for example, I have graphed over here, y is equal to, or f of x is equal to, the square root of 4 minus x squared. It makes the top half of a circle. So the domain, either by doing interval testing or by looking at the graph, I can see that the domain are the x values from -2 to 2. So I will express that as -2 to 2. The range, in other words, the y values that get used, well, none of the y values down here get used, but starting at 0, right, those y values are being used. So from 0 to 2, that's my range. Symmetry, this graph has y-axis symmetry, and since it's a function, with y-axis symmetry, we can also use the word even. It has even symmetry. Its zeros, in other words, its x-intercepts, are at -2, 0, and 2, 0. So plus or minus 2 and 0. That's a point. Relative max and min means if you look at the graph and you can find what they call a small neighborhood, like a little circle, where there's a point on the graph that's higher than any of the ones on the left of it or the right of it, then that is a relative maximum. If you can find a place on the graph where in a small neighborhood, all the points on the left and the right are higher than a particular point, then we have a relative minimum. And this graph right here, right, if I were to put a small neighborhood right here, all the points to the left and to the right of that particular point are definitely lower, so that's a relative max at 0, 2. Increasing, decreasing, and constant. That happens as we look at the graph. We look at the graph like an amusement park ride. So would you agree that if we were on the sidewalk right here, walking along, because we don't get on the rides, you have to do increasing, decreasing, and constant, you have to be afraid to get on the ride. So if you're walking along the sidewalk, would you agree that the people on the ride, as you're walking from here to here, they're going up. So they're increasing. And as you walk from here to here, they're decreasing. So they're increasing from -2 to 0, right? That's according to you, from -2 to 0. And they're decreasing from 0 to 2. Different texts use brackets and parentheses. Some use all brackets. Some use combinations of brackets and parentheses. We'll talk more in detail when we have more time. Okay, here's another graph. This graph shows f of x equals 1 over x minus 2. And so the domain, well, let's see, the x values that get used are all of them up to 2, but 2 doesn't get used, as shown by the vertical asymptote. And then from 2 on. So the domain, -infinity to 2, united with 2 to infinity. The range, well, let's see, the y values, all the y values get used up to 0, and 0 doesn't get used. And then from then on, so from -infinity to 0, united with 0 to infinity is our range. It does not have y-axis symmetry. It does not have x-axis symmetry. And it does not have origin symmetry. Because if I wanted to rotate it, I'd have to rotate it around this point. So it has none. Zeros, in other words, x-intercepts. Well, this graph is never going to touch nor pass through the x-axis. Relative maximums or minimums. There's no place where I could draw my little small neighborhood and have every point on the left and the right, at some point in there, be higher or lower. So we also have none of these. As I'm walking along the sidewalk, the people on the right are going down, right, as I'm walking along the sidewalk. And by the way, as I'm walking along the sidewalk, even though they seem to like leap into the air, they are going down. So this graph is never increasing. It's never constant. It is always decreasing. But we would express that as negative infinity to 2. Negative infinity to 2, they're decreasing. And also 2 to infinity, they're decreasing. Because there's this little loop out at 2 itself. Okay. This graph is supposed to look like part line, part ellipse, part line, but I drew it by hand. So the domain, so walking along the x-axis, seems like every x value is going to get used. So we have negative infinity to infinity. The range, well, the values down here don't get used, but once I get to negative 2, all the y values from there get used. So negative 2 to infinity. Symmetry, we have, again, y-axis symmetry, which would mean we could say it's even. Zeros, oops. Well, if I had drawn this more carefully, it would definitely look like 2.5 and negative 2.5. I didn't draw as carefully as I should have. So plus or minus 2.50. Relative max or min. If I draw a small neighborhood around this point, this exact point right here, every point on either side of it is higher than that. So it is a relative minimum at 0, negative 2. This graph, as I'm walking along the sidewalk, is decreasing. They're still going down, but now they're in sort of a roundy going down until I get to here. And then they're increasing, right? They're going up, 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 up from there on out. So it was never constant. They're decreasing from negative infinity until I get to 0. I guess I could bracket that if I want. Really, it doesn't matter. And then they're increasing from 0 to infinity. Remember, for these, your interval should be on the x-axis, describing what the graph is doing. So while you're walking from negative infinity to 0, the graph is decreasing. And while you're walking from 0 to infinity, the graph is increasing. Okay, that's a brief look at what's going on.